Hi, I'm Harry and I'm a mechanical engineer and PhD student with Free Running Buildings, currently working on Freecool Plus in Kenya.
My name is Liz Nyukuri. I'm an energy engineer with Innovators.
Hi, I'm Hassan and I have done my master's in mechatronics engineering. I'm doing my PhD right now in mechanical engineering. I'm working with Free Running Buildings and I'm here today in Kenya working for the Freecool Plus project.
So we're a company operating out of Sheffield in the UK. We focus on the built environment and low energy solutions. We're looking at a multitude of research projects and also commercial projects installing passive ventilation and heat recovery devices into buildings to reduce the amount of energy that they use through heating and cooling.
Our role as Innovators is that we are the local partner in this project. We're involved in investigation for the demonstration sites, and we settled for a site currently in Kakuma. And we were also involved in the pre-design phase where once we identified the site, we were able to carry out an energy audit on the site, install monitors to capture the baseline performance of the energy consumption here. And now we are in the implementation phase. We are in partnership with Free Running Buildings where we are installing the wind towers, and we cannot wait to see the impact it will have for the classroom that we are setting up the wind towers.
Hi Liz.
Hi.
How is the going?
Great.
Excited because there's a lot that we get to learn from Hassan and Harvey about this initiative, and we look forward to putting up more of this infrastructure in different parts of Kenya.
So in this we're looking at a Freecool Plus unit, which is a passive ventilation wind tower combined with a cooling system using heat pipes and Peltier coolers. So the wind towers work they allow air to come in through one side through the louvers. This creates an area of positive pressure on one side of the wind tower using the internal cross divider, and then you get an area of relative negative pressure on the other side. So this means that the air wants to flow from positive to negative. So as it comes in through the inlet, it goes into the room, hits the floor and spreads out throughout the room. It then looks for an area of negative pressure to flow out, and so it goes out through the outlet on the other side. And through that you get a flow of air through the room and over the wind tower. In between this, the cooling happens using heat pipes and a Peltier cooling system. With electric charges applied to a Peltier cooler, which creates a cold side and a hot side. By attaching the cold side to the heat pipes, this creates basically a heat sink for the hot air coming in through the inlet and cools it as it passes over the pipes.
So if you can see over here, we have a lot of heat pipes, and this is the wind tower. I think Harry talked about this before. So we've got, this is upside down version of it, and we have an incoming air that needs to be cooled. So the way we are cooling the heat pipes are through these Peltier modules. Now these little devices, we are going to use 35 of them. What they do is when you have electricity, if you have power on them, it cools one side and heats the other side, and the heat needs to be dissipated, right? So we are using aluminum heat sinks to dissipate the heat with the help of some fans, and this will be circulated within the wind tower when the fresh air comes in. So this part is where the heat gets dissipated, and the rest of it, the bottom part, is touching with the heat pipe. So this is the cool side that's touching the pipes. So all of these pipes will be cooled to about 8 to 10 degrees lower than the ambient temperature, and that's how we're basically cooling the incoming air which passes through the pipes.
Hi Hassan.
Hi.
How is day 4?
Amazing. Job almost done.
My experience has been quite eye-opening. It's been quite fun to have the team from Free Running Buildings, Hassan and Harry, join us. So a lot of learning opportunities, and cannot wait to see the impact that the wind towers will have in this place in Kakuma.
Why did you choose Kenya and Kakuma in particular?
Kenya obviously has a lot of regions where it's particularly hot and areas that are also off-grid. So areas that are off-grid are reliant on things like diesel generators that are particularly expensive and polluting to run. So this creates a good opportunity to install energy systems that are run solely on solar power to reduce the energy consumption and save money in the meantime.